Welcome, everyone. My name is Beyza. I'm research scientist at Cohere for AI, and I'm very excited to introduce our guest today, Minjoon Seo. Minjoon is an assistant professor at KAIST AI, where he's the director of Language and Knowledge Lab and the chief scientist of 12 labs. He obtained his PhD in computer science at the University of Washington. Before that, he obtained his bachelor in the University of Berkeley. Minjoon's research broadly centers around the question how the world knowledge can be encoded and accessed, and how new knowledge can be discovered and retained. During our conversation today, we will learn more about his career journey, and please feel free to drop questions in the forum throughout our conversation, and I will be sure to give some time at the end of those. Minjoon, very excited to have you here today. Welcome.
Yeah, thank you for the introduction, and yeah, go Bears.
Yeah, okay, cool. So in the first part of our conversation today, I would like to learn more about your research journey. When I was checking your website and the publications, I noticed that we both started machine learning research around the same times, before the era of transformers and even the rise of neural networks. And I'm curious, how did you first get into machine learning research, and what was the initial topic you worked on?
Yeah, I think I'll probably have to go back about like 10 years. So I think the and it's not really a long story. Actually, I think I liked AI since I was an undergrad, because it was more of a I like robots, and I like these movies that have robots and also these AI. So I don't think there was like really super special reason that I wanted to do AI, but I think I didn't really do AI until I took a AI class in my last year of undergrad. I remember that Dan Klein was teaching the artificial intelligence class, and back then I was actually supposed to go to a company for software engineer job, so non-AI job basically. But then I think taking that class, I really thought that I like AI, and I asked people around, and okay, what should I do if I want to do AI more? And I think people back then said you should go to grad school. So then I have to prepare for grad school. So I was looking for some research internship in the school right before I was graduating. So I think I wasn't really preparing for this, I think, early enough. But yeah, it's nothing really special, I think, back then. I just didn't know, to be honest, what I should do. And I think back then the AI was the most interesting thing to me. But as you said, it was before transformer. It was before even like most deep learning techniques. Right before deep learning, to be more exact, because I remember that in 2012 there was a lot of I think hype in the image classification because of the ImageNet challenge that the Toronto team won with the neural network. So I think it was right at the verge of deep learning, but still in like most fields, still in most subfields of AI, people were just using SVMs, logistic regressions, or rule-based systems. So yeah, I think I was quite lucky in that sense, because I was able to go through I think experience basically not just the post deep learning era, but also 1 or 2 years of the pre deep learning era.
Yeah, actually same for me. And yeah, the first assignment in the AI course that I took in the bachelor, the first assignment was naive Bayes implementation and the classification of the iris data set. And
Yeah.
I was super impressed by that, how it works and how you can predict some other data from the future. And
Yeah, certainly. I think it was SVM for you. I think it was MinMax for me. I was actually working on this Pac-Man project that Dan Klein actually created. So it was actually quite popular, I think, among the professors in the US, because I saw that other schools were also using the same project for their AI class, and this AI class wasn't really about I think SVMs or these machine learning, but more of I think basically search problem, making good move. I
Yeah.
think we also actually did a bit of a probabilistic models like Markov chain, so that we could do some, I would say, smart decisions based on the partially observed environment.
Okay, cool. Also, when I was going through your publications, I've seen you worked on many different topics. How do you decide on what topics to research, how to navigate across different subfields in general?
Yeah, so I think in general, well, I mean, I think the reason why I chose NLP was also, I don't think was very intended initially. I think back then I was interested in solving some reasoning problem in math, more specifically geometry problem, which is, I think, well, these days we can consider them to be relatively, I think, maybe solved relatively, but back then basically people wanted to solve like geometry problems that appear in high schools or middle school. And initially I thought that the problem is about really vision, but then at the end, I think because it involves a lot of reasoning, it was really about language. So I think that was why I really wanted to do language first, because I thought that if we want to do some reasoning, then language was the bottleneck back then. I think still maybe, but so I
Right.
think yeah, but then after that, I think, to be honest, so I think initially the biggest difficulty was, well, I don't know anything about AI. I didn't know anything about AI, anything about deep learning. So it was really hard to, I think, choose one topic. But then after I became quite familiar with one of them, um, after that it became easier, I think, because it just followed what I'm interested in. And it just happened to be, I think, some well, language models or these language related stuff, but I don't think it was really planned or intended back then.
Right. Yeah, I can also suggest to the audience right now, if they're just uh, just starting their research journey, to explore a bit before converging to some field. Maybe you can open to work on different fields without so much bias. And yeah, just to be open and flexible to work on different things. I think it's very useful, especially for the early stage researchers.
I definitely agree. Yeah, I think so, because I think, and I also think, of course, we don't have to, of course, work on, um, I think, just one thing. And usually I think what I think the easiest thing is that working on what I'm interested in, what I'm excited about. Um, and if that's actually something that also matters uh, to the industry and the world, then I think that's the best.
Mm-hmm.
If not, then maybe it's a choice between am I doing something that interests me, or is doing something that actually can well, impact the world. Then there'll be a, I think, harder question. But yeah, in many cases I think people like to be creating some impactful products. So at the end, I mean, of course, even if you're doing research. So I think usually it's not that much difficult, I think, to really, I mean, if you are actually working on something that you're excited about.
Yeah, yeah, I totally agree. Yeah. Also, I'm very curious about one thing. After obtaining your bachelor and PhD in US, what was the main motivation to get back to Korea?
Oh yeah, I think there's a very simple answer actually. I had to actually go back to Korea for military service. So
Okay.
yeah, so it wasn't really complicated decision back then. Yeah. So I had to actually serve 3 years in
Mhm.
Korea. I was actually working at Naver. It's a IT company basically doing search. But then, of course, not just search, but they actually do a lot of different things. It's kind of similar to Google, I think, in the US. I think maybe the question matters more. I think if you ask, for instance, why did I decide to stay after the military service?
Yeah.
Um, so I think I was actually really debating between going back to the US and staying in Korea, to be honest. And I think there were several, well, considerations, but I think one thing was that there were a few, I would say, topics that I really wanted to delve into if I go to academia. So I was actually debating between going to academia and industry back then. And I think what drew me to industry was that I think I was really excited about doing a few topics, not just one, but a few topics that I really was excited about. And um, uh, I think if I went to industry, then probably I would have been a research scientist. Then probably I would have been working more on one topic in depth, and that's also, I think, very very good thing, and that's very exciting too. But I think back then I just wanted to tackle a few different problems at once, and I think that was not sure that was really, of course, well, I would say, um, I'm not sure actually it worked as I intended, but then I think I thought that KAIST is basically one of the best schools in that I would say aspect, because I could scale my lab quite quickly. So I could hire a lot of students, and also not a lot, but I think enough number of students, really good students, I think, and they could work on the problems that I was really excited about. So I think that was the biggest thing. And also I thought that yeah, staying in Korea was really it's been a few years that I actually had to well, I've been staying in Korea for 3 years when I was making the decision, so I think it was relatively comfortable for me too. Yeah.
And are there differences between research culture in US and Korea? Have you noticed some differences?
I think I don't think there is a big difference, to be honest. I guess the biggest difficulty usually is that probably it's not just Korea, but I think for all non-English speaking countries, there are a lot of very very brilliant students, but they usually struggle with English communication. So I remember that when I was setting up the lab initially, a lot of my time actually went to helping them to actually communicate in English better. So, and I think that paid off a lot, I think, because later on, the students in the lab were able to actually help the younger students, and then well, then I was able to actually, well, spend less time on English teaching, and I would say more on the research that matters. Yeah.
Okay, yeah, sounds good. Shifting to your current research interests, I would like to start with a question about language models. How is world knowledge encoded in these models?
Yeah, so that's very I think good question. I think, and it's a really interesting question, because if we go back to, say, 2019 or 2018, we were not really sure whether language models can encode knowledge. And I think back then, how we thought of a language model or something similar was more of a, I would say, function that can do classifications, or they actually have some knowledge about the, of course, like syntax, lexical stuff, and also how things work, but then not actual factual knowledge of the world. And without that, basically, of course, we cannot really ask a language model to do anything really meaningful end to end. So, and I think in 2018, around the time when the BERT got popular, actually BERT came out in October of 2018, and in like 2019, people were actually exploring whether language model can actually encode these factual knowledge, and they were finding that, well, actually, the language model was memorizing some facts inside it. So I think the short answer is that, of course, these world knowledge is encoded in language models because when they're being pre-trained, they're actually trained to predict the next word. And that next word is basically, in many cases, the factual stuff about the world. But then I think it's not been a long time that we found, the community found that the language model contains such knowledge. I would say as early as like 2019, but probably not before that. So not only like 4 years ago, I think. So it's very, very, very recent thing. And I think in that sense, probably model like T5, which Google released in 2019, in later 2019, was very, I think, stepping stone in this part, because they found that after training T5, they were actually they fine-tuned T5 on some question answering pairs, and they found that actually with just language model you can answer questions, which is like so obvious now. Like, I mean, everyone knows, right? But then back then it was like really amazing finding that like everyone was shocked, because they thought that if you want to do question answering, you have to actually retrieve documents from the web and then put that as an input to the model. But then they found that, oh, you can actually just fine tune with question answering, and you can get these facts retrieved from the language model's parameters, presumably. And there are a lot of course, concerns that, oh, no, actually, they're not containing information. They can only answer maybe questions that were trained. But that turns out to be not true. I mean, there were some claims, though, back then, like in early 2020s. I think looking back, it was not true, because we now know that they can actually generalize to every information that the model learned during pre-training, even if that information didn't appear in the fine-tuning stage of question answering. But there are many people believing that in early 2020, oh, that's working because you're memorizing what you trained during your question answering fine-tuning stage. So I think it's, so in that sense, I think when the time that when the community accepted that language models can reliably contain some information and we can actually extract these things is probably not sooner than 2020. So it's a very recent thing. I think it's quite amazing, I think, that how the community progressed so fast in the last 3 years.
I totally agree. And I'm just as a side note, I'm super impressed by how you remembered the developments by date, the history of language models. It's amazing.
Yeah, I think that's the good part of I think being in this area for a long time. I think I remember that I was actually today's morning, I was in another talk by Hyungwon from OpenAI, and he's actually coming from physics physics major. So he did PhD in physics, and then he actually he changed his of course I would say main area to language model. So I think, and then I remember he was saying that, oh, like the field is changing so fast that there is very small advantage of people who are working on this for a long time. And I agree, actually, that's actually completely true. Because sometimes it actually even hinders well, new ideas, because you actually tried a new idea before and it didn't work, but at some point start to work, right? So that's why the newcomers actually have advantage in that sense. But I think one big advantage of being here for a long time is that I could be probably very good at remembering things of the history. Yeah. So I can tell quite good stories of them, at least.
But
Yeah.
feels like there are some sad stories behind it.
Yeah, true, true, and that's a sad part, but that's something we have to accept, I think, and
Yeah.
at least I can be a good storyteller. Yeah.
Yeah. Yeah, that's yeah, totally true. Building on our team, ever evolving language models, how would you define ever evolving in the context of these models? What aspects of the language models are continuously changing and what drives this evolution?
You mean the assume the language model research in general, or is it more of a language model in the deployment of a
Yeah, in
service?
the deployment. Yeah.
I see,
Model
I
Y.
see.
Yeah.
Yeah, I think that's also quite timely question because I think, for instance, like well, like we had a OpenAI Dev Day yesterday, or was it 2 days before?
Yeah,
Um,
right.
and I think they were saying that they updated the cutoff to very recent date, which is like 20
Mhm.
I think this year's April. And I think it was also interesting that I think not, of course, not just OpenAI, but I believe Cohere too, and also other language model
Mhm.
companies too. They actually care about the cutoff date. And if you think about that, I think there are at least one aspect of the language model being dynamic as we go, which is, well, if we just actually pre-train on up to like 2021, then it cannot know anything about 2022 or 2023.
Mhm.
That, of course, also could bring a question: do we really need to be up to date? Because let's say if we use something like retrieval augmented generation, then we can retrieve some documents, and well,
Mhm.
those documents can be then your the basis of whatever question you ask to that model instead of the knowledge inside the parameters. So I think it's a not easy question to answer because why does like cutoff date matters then? Like, I mean, why are we really trying to um, make the language model always up to date? But one thing for sure is that if we decide to make the language model up to date, well, especially if we want to make it well, not just like once per year, but at least like something like once per month or once per like week, we want to update the model,
Mhm.
then it becomes a very I would say important computational problem because, well, let's say we pre-train the language model, then these days at least it's known that it's not, of course, it's not verified, but then it's probably true that we do not usually go beyond one epoch of training the corpus, pre-training corpus.
Mhm.
So, which means, well, then maybe the easiest way is that, okay, let's just train the model from, let's say we had a cutoff date of 2021, then we can just pre-train the model on the entire corpus until 2021. And when we want to update, let's say we have a new corpus to update, then okay, let's just continue the pre-training because anyways, we were actually anyways on the single epoch, so it's like kind of same thing. But
Mhm.
then in many cases, it doesn't work as intended. And that's actually very important, I think, problem because I think there are several known issues and I think there are several issues that we do not know why. But then the thing is that it just doesn't work as continuing the pre-training in many cases. And the problem is because in many cases, if we are not careful enough, we are faced with catastrophic forgetting, and also we'll face other issues that would be easier to solve if we actually just decide to pre-train everything from scratch. So I think I just wanted to not make this too long, but I think short answer is that if we want to keep the language model up to date, I think which is probably true for many applications, then now a lot of issues happen because of the especially in the forgetting part, and also in the um, I think the forgetting is probably the biggest issue here.
Yeah. For the ones who are not so familiar with catastrophic forgetting, can you just briefly explain what is catastrophic forgetting and why it's such a critical issue in the training of language models?
Sure. Yeah. So I think probably the best way to describe it is as follows. So I think it's actually not coming from language model research. It's more of a older term. Actually, it's coming from, I think, early days was mostly in the vision community, and in fact the way that they formulate this problem was really interesting and maybe not so natural. It's kind of synthetic because what they were doing is they had a what the setup is like this. You have a single classification model, but then you first train this with one data set. And then you just want to, after you train the model, of course, you now have a classifier for this data set. But then after that, you actually have a new data set, which is different from the first data set, but still classification. And then you want to actually train this on this data set, and you continue training on that data set with this with the model that just with the model checkpoint. Then people observe that as you actually train this model on second data set, the model performs really poorly on the first data set. And that's, well, there are several reasons for this, but the easiest way to explain is that probably distributional shift, because, well, I mean, exactly because, well, you're optimizing for first data set, but then you now turn to second data set. So it's not too surprising that the first data set is no more working on the model. But then if you think this in a different way, why is that really a problem? Because if you actually do multitest training instead, like let's say you have a data set that's just mix of first data set and second data set, then it works well. So it's not, the forgetting doesn't happen at all. So the community was very interested in this issue because, oh, multitext learning is good, but then the problem is that in many cases, it's the data set will not be available at once. You will have one data set and then you will have another data set available later, but you will have a model that was just trained on data set one. So you have to actually deal with that. You don't want to retrain everything because they'll be so computationally costly. So that was the I think birth of where the catastrophic forgetting was mainly discussed in I think mid 2010s, so basically like 2015 or around that. But that actually had well, the issue is that but then why would you want to do that? I think that was like the biggest question I actually had when I heard about that. Like, why do you want to actually use same model to train different data sets? Can't you just use a different model? And I think that was exactly why people are actually working on them, but then it wasn't really very realistic problem. Well, until I think people started to deploy these classification classification models, and they saw that, oh, actually, it's not that you will have a fixed data set and the served model continuously without any change, but the problem is that in many applications, the inputs, the type of inputs that are coming in change as the time goes. So that's actually different from how people actually do in the pure research space, because in the pure research space, we assume that the data set evaluation and the training are fixed, but then it's very common that in practical applications, the type of inputs that come in change as the time goes. So then now people realize, oh, it's really actually an important problem because yeah, it is actually very practical issues. And I think that now came to language model, I think, and I think we're our lab was lucky to actually work on this in the early stage. We actually work on this well, I think a lot in 2021 and 2022. So it was relatively early stage for handling this kind of problem, because language model, in the same way, we want to update language model as we go, because the information gets outdated, and the question you asked was, well, language models are able to contain factual information, which translates into the conclusion that if you want the language model to be up to date with the factual information, then we have to update language models because, yeah, apparently for apparent reasons. So then now catastrophic forgetting actually was again seen, which means in this case, let's say you train on new corpus, then you now acquire information in the new corpus, but now you start to see that the information you should have acquired in the first pre-training corpus starts to get diminishing, which means the model is not able to actually retrieve that fact anymore. So, and it's not just about knowledge, it's actually about also other things. So that's exactly why I think a lot of people who are relatively new to language model fine-tuning, if they do not fine-tune this well, which means, like, let's say they put too much time on fine-tuning, or they do wrong learning rate scheduling, then sometimes they actually see that the performance degrades a lot, and that's because of forgetting of what the ability that were actually learned during pre-training. So it's not just about, I think, factual knowledge, it's also about how the language model does different tasks.
Yeah. When I listened to that, it made me think that is forgetting always unintended, or sometimes it is intended? So how we can utilize forgetting in some applications maybe, or how can affect forgotten in language model on purpose?
Yeah, that's actually quite related to the work we did last year, which is in fact about unlearning, which is sometimes quite important if we want to do if we have some like privacy concerns. For instance, if language models attain some information, but maybe it's too costly to retrain the model without that information. But then now the question is, can you actually go back without that information? So I think it's not easy, to be honest. There are ways, but I think it's not easy. So I think the research is still going on, but I think simple answer is that probably unlearning is harder. Easier way is probably we try to, if those information is like for instance, like some private information, then through some fine tuning and things like, for instance, like RHF, we can make the model to avoid getting any information to the user. I mean, such private information to the user, but it's also a question whether that information is really unlearned, or it's more of the model knows it, but then just doesn't, spit it out.
Yeah. Also, the benchmarking in the mainstream continual learning was very different back then. So most of the benchmarking was like just on splitted MNIST, splitted CFAR, which is super artificial and toy settings to just evaluate the performance of the neural network. But with the foundation models, I think evaluation of the language models also changed in the concept of language model retains knowledge. So what do you think, what are the key considerations in designing benchmarks, scenarios, and appropriate metrics for assessing continual learning, especially with foundation models? And to understand how can we evaluate how well a language model retains knowledge? Sorry for the very long question, but just wanted to.
Basically, how can we create good benchmarks for
for those models and for more realistic settings?
So I think it's a really difficult problem, because the reason why is although I'm not saying we cannot do it, we also try to do that. I think our papers also highlight that, but I think it's a really difficult problem because, you cannot test every knowledge in the world, and you have to actually choose a few of them and then see if the model is able to attain them. So the best we can do is, let's say we have a few samples of facts, and like question answering, for instance. I think the easiest way to put this is that it's like same as like humans. You ask the models a few questions that the model should know if the model actually learned the corpus up to that date. So I think that's probably the easiest way to really do it. But the problem is that, I mean, probably it's quite apparent, but it's really hard to know whether a model forgot some fact or not. So it's more of a proportional thing, I think. Okay, on average, the model gets, I mean, we have a samples of evaluation samples, then the model gets right on these evaluation samples. So that's maybe fine, but at the end, I think it's quite a difficult problem. But I think the probably easiest way to really approach this is that we basically create a question answering data set, but then that will be more of a streaming question answering, not just single time I mean, question answering data set from the single time stamp. So we'll have a different questions and different answers depending on the time. And we can basically see, for instance, when the present changes, then we can see whether model can actually now answer the new answer instead of the old answer. So I think that's probably still the best way. Although the issue is that, well, then you have to create the data set every time the world changes. So that's very costly. So we'll have to think about automated way if you don't want to spend too much money on that.
Yeah. Yeah, one last technical question. So most current continual learning systems operate in the unimodal regime, like LLMs are only for division models. And only a handful of works study multi-modal models in that setting. So what are the main challenges in developing efficient tools that effectively combine continual learning and multi-modal learning systems?
Oh, sorry. So, do you mean a tool that can combine? Well, how can
Yes.
we?
Yeah, so I mean that your data could have multimodality, not only text or not only image, not only speech. So what are the main challenges to design such a system that you have a data stream which is coming all the time and you still need to update your model, but your model is multimodal this time? So is it different? So do you need to consider different constraints compared to language models, or for example, updating ResNet or updating BERT?
Okay. Yeah, actually, that's a very good question. So actually, I think that's exactly where what we at 12 Labs actually is really concerned about, because 12 Labs is working on multimodal models.
Yeah.
I think in general, probably the continual learning is more challenging in the not challenging, I would say it's actually probably challenging for probably maybe more challenging for multimodal domain, but then it's more concerning, I think, in language model side, which means like non-multimodal side, because what we want to update is knowledge about the world. So we in language model, usually how we use language model is that we ask a question about the world and we expect that the language models to contain that information. So that's why the continual learning is really, I think, crucial in language models. In multimodal models, in many cases, the question will be about the given, well, modality like image, video, or something else. Then in that case, then it's not really about the knowledge being updated. It's just about the exact the input that the model is given. So relatively, we don't have to worry too much about it. But still, there will be issues because, of course, as we train larger models, and if we just want to improve that model, the question will always appear. Do we want to train that from scratch, or do we want to continue pre-training with the new data? Especially if we are collecting these web crawl pre-training data, and as we collect more and more, that question will be really important to answer. Exactly because well, we don't want to probably train every time, but also the issues become more complicated if we actually decide to just continue pre-training instead of retraining. So I think it's not just because multimodal has some modalities, but in general, I think if any model involves large pre-training step, then the continual learning is very important. I think to be more exact, I really want to put in on another way. We want to be more aware of how the language models learn and I think forget, and also how things get shifted. So that's something that I think is relatively, I think, more theoretical and mathematical, because it really deals with how we actually think the model learns things. So that concept will be, I think, very important in general.
Yeah.
Yeah, for even for multimodal models.
Yeah. Yeah, I agree, by the way. Okay, so I want to move to the last part of our conversation. Then I'm going to open up for audience questions. So you can start dropping your questions to the chat. So can you name one paper which is very influential, even influenced your career or your growth as a researcher?
That's a very hard question.
Yeah, I know.
Yeah. I think, of course,
No,
there
no is
was.
an answer too, by the
I
way.
see.
But
Yeah, I think there were
yeah.
several papers definitely that were influencing me a lot. That influenced me a lot. Um, I think um, in I- I'll probably to try to choose one per I think like 3 years, I think, something like that. That's probably
Mhm,
because I think if I try to choose just like influential papers, then probably most will come from the recent ones.
mhm,
But then I think, as you said, actually, your question is about my career, not the impact on the my research. So
yeah.
I think
So,
then it makes more sense. I think I remember that in 2015, I was still working on very traditional machine learning based models. And back then, I remember that all the NLP people were debating between whether they should go to deep learning or not. And I remember a lot of people who are really good at right now, they're like stars in these language model domains. I remember
mhm,
they were saying, they were like my PhD friends, and they were saying, oh, deep learning is like it's really, BS. So I think people were really debating between going to deep learning and not back then. And I think many people, were, especially in NLP, were reluctant to. But I think the paper that really changed my view was there was a paper from back then Facebook AI research, basically Meta. It's called uh, Memory Network,
mhm,
and it's actually the model itself actually was only tested on very synthetic data sets. So at the end, I think probably, well, at least the paper was tested on the synthetic data set, and also the vanilla model probably wouldn't work in real language scenario. But then I think that paper was like very super influential to me, because actually that opened my, I think, eyes on how things could be viewed. Um,
mhm,
back because before then, of course, I wasn't in the deep learning, but also I think it was really very very I would say I was actually shocked by how they could actually model these things with such networks. So I think memory networks, especially end-to-end memory networks in 2015, I believe, that was like very influential to me. I think that was probably in my early PhD career. I think the next one was, I think, is certainly probably as many people choose BERT,
mhm,
which was very, I think it's for very apparent reason. It was, I think, opening an entirely new era of large language models. Although I think people probably these days credit less, tend to credit less, because people are all using more of a autoregressive decoder-based models, but I think BERT was played very big role there. There were too many papers, I think, very recently, so
Yeah, that's
so it's
right.
hard to
Yeah.
choose. Yeah. Okay. Yeah, but I think I'll just choose those two papers for now. Yeah.
Okay. Yeah. Research is tough at times. And yeah, sometimes your hypothesis doesn't work and you only can learn it after months of work, or everyone has ups and downs during PhD, for example. And what was the most challenging period or thing in your career?
Um, I think it's probably the same for most people, but I think it's when of course research doesn't work. Um, yeah, so I think for me that was like I think around my third year of PhD, which was right at when I was basically changing my well, I was going into deep learning,
Mm-hmm.
and I guess like they're probably quite cliche, but then I just wanted to say that one thing that I kind of always wanted to tell when I think people ask questions like what you ask is that yeah, I think um, to me I think the paper that kind of well the I probably I mean of course there are several papers, so I don't think one paper is especially more better than the others. But I think the paper that probably was, I would say, most important to me in terms of my career, I
Mm-hmm.
think was that project was conducted when I was most stressful. So and when I was and also very most I think um, struggling with my PhD. So um, I just want to say that maybe to see it on bright side, I think usually really good research happens when you're under stress. So maybe if you're under stress, it's not a really bad thing. But I just want, of course, I don't want to say that. I don't want to like put yourself. I don't want you to put yourself into stress for that. I think that would be probably not the wisest thing. But I just wanted to think the other way. If it's really stressful and you're doing research, then I think, of course, you hear it being very general person. Then I think the good thing is that usually I think the best research is actually the best research actually I think they are actually done when a person is under I think a very stressful environment.
Yeah,
Yeah.
that's true. Also, yeah, it's never that easy. Sometimes, yeah, sometimes you can be a bit more lucky and your research ends up with a reward, but it's not always like that. I think that's the general thing in research, and you should accept this in the beginning.
Yeah, I agree. And also I think
And yeah,
also
maybe shouldn't give up so easily, but more deterministic.
yeah, that's I think always a really difficult question. I think because the definition of research is I think really working on something uncertain. In other
Yeah.
words, if things are certain, then probably it's not research. So then I can only work on certain things today. So it's really a really hard question how we can actually go towards that. And I think that's something that we have to learn, yeah, as we go.
Yeah.
I
And
feel.
also, it's part of the learning to me. Maybe later on, you
Yeah.
also realize which idea is more promising or less risky. But in the beginning, I think it's also part of learning, and maybe you should take that risk and learn if it will work or not. So,
I
yeah.
definitely agree. Yeah, I think it's part of learning too. Yeah.
Yeah. And so last question. So you have some PhD students and master students, and given the crucial role you play in the development of early stage researchers, what advice would you give to your peers in these positions? So how do you think a good supervisor should guide their students?
Okay. Yeah, that's very good question too. I think I learned a lot from my advisor. So which is something that I did not appreciate back then. But then, yeah, I think that's always the case. I mean,
Yeah.
something I think remember that my advisor said kind of in a similar way. I think it's really hard to appreciate that when I'm being advised, when I'm a student. And
Mhm.
then later on, when I became professor, um, I think then now understood why my advisor was doing this thing this way and that thing that way, and why that was actually very great thing. I mean, which I thought back then was not. So, and I think I usually try to when I have to like make some decisions, and I think these are usually like soft decisions, not like
Mhm.
some technical decisions, but more of for instance, how I should like when there's like for instance some troubles going on, or when there's like if the research is not going as intended, and like how should I actually I know how should I say things to my student?
Mhm.
Like these things are something that I usually try to think like, oh, um, what did my advisor do, or how would my advisor have done if she was or he was in this situation? I think that really helped me a lot because that way because I think that's the really good way of thinking because I know that my PhD was very satisfactory. I mean, like I was really satisfied with how my PhD went,
Mhm.
which means probably my advisor was able to well provide such environment. Then I try to actually think in that way. Then it helps me to actually make some. Well, I'll say it's not probably make helping me to make the best decision, but at least it helps me to avoid very bad decision. I think, and I think I think that really was helpful for me too because I think um, yeah, probably as I said, I don't think I made the best decision every time, but I don't think I made a really bad decision either for the last 2 years. So and that was very helpful. Yeah. So
Okay.
maybe yeah, that was like one way to think of I think one way to I think start career as a I would say um faculty member
Mhm.
without much hassles, I think.
Okay. Yeah. Okay. Great. Okay, I will now check the Q&A and audience questions. So yeah, there's one question. What will be your advice to PhD applicants in the NLP fields, given such a fast paced in research field? What would be the main perspectives that you as a professor looking for?
This is something that I learned relatively recently too, but I think if we look at the applications, it is true that the field is changing so fast.
Mhm.
But if we actually look at the how things work, I don't think it has changed um, as fast, which means, of course, we have found new things, but I think how things work is still relatively happening gradually. And that's I think quite similar to I mean understanding basically how deep learning works or how deep neural networks works and these days I would say how like transformer works, how like the training works, how this is affecting other things. So these are more of a scientific questions, I think. And if you're tackling these questions, then I believe that they are not the beliefs that the community has is not changing that fast. So so I think it's a maybe good thing because I think a few years ago when the applications were, I think, the mainstream in the academia, then you had to actually be very fast follower of the state of the arts. Otherwise, your paper is like meaningless, right? Because well, you put some model out, but then the model is not the best in the in the community, then people will say that, oh, your model is actually worse than this paper. So your paper actually is not meaningful. But I think because of that constraint, that as the question says, I think the academia is anyway has to move towards understanding how these deep neural networks work. And I think maybe some might think that, oh, but then isn't that too passive? Because, well, understanding is not really creating an application. It's more of a analysis, and it's very passive thing. But actually, do not think so, because these days, I think if you want to create a really great thing, I think it becomes more and more important that you understand what you're creating, rather than just trying to create with try and error. Although I'm not saying try and error is a bad thing, but I think trying and error with direction in mind is, well, it's like entirely different thing than try and error without any direction. So, and here the direction, I think we call hypothesis. So basically the hypothesis is like how we understand the problem, or how we understand that some certain nature of a deep neural network. So I think that's it actually enforces many students, including I think me in academia, to think of problems in a more I think scientific ways than before. So so I think that's like one important thing. But I agree that still it is more stressful. Yeah, it is certainly more stressful because there are so many things happening every day. So I think it's stressful for everyone because it's so fast paced. So I think maybe another thing is that it's important to have a very good strategy to control your mental health, because otherwise many people will, I think, be very depressed.
Yeah.
So I think that's also, I think it's not an option. I think it's very important that you have a very your own way of controlling the stress and also mental health.
Yeah. Yeah, thank you so much for that very valuable advice. I think it's also, yeah, I also think it's so important. Okay, we only 1 minute left anyway. So thank you so much, Minjoon, for accepting our invitation and for that lovely chat. Also, thanks everyone who attended and for their interest. Yeah, thank you so much.
Yeah, thank you for inviting me. It was a pleasure to have a fireside chat here.
Yeah, okay. Thank you again. And
okay,
everyone,
thanks a lot. Yeah.
Good day, good evening. Bye-bye.